In this exercise, we will use the definition of infinite limits to show that the limit as x approaches 5 from the left side of the fraction 2x plus 3 over x squared minus 25 is minus infinity. Before we get started with the proof, we call attention to the fact that 5 has a minus superscript in the limit notation. What this means is that x is approaching 5 from the left side. That is, x starts out less than 5. We write the limit of f of x as x approaches a from the left side is equal to minus infinity if and only if for every capital N less than 0, there exists delta greater than 0 such that f of x is less than n if or whenever 0 is less than a minus x is less than delta. F of x is equal to 2x plus 3 over x squared minus 25. We already know the value of a equals 5. The definition also mentions two other numbers. The first is capital N, which is negative, and the second is delta, which is positive. The relationship between capital N and delta is such that if or whenever 0 is less than a minus x is less than delta, then f of x should be less than capital N. We start the proof with the inequality involving capital N. We start with 2x plus 3 over x squared minus 25 is less than n. From this inequality, we proceed to obtain the delta inequality. We aim to get the inequality 0 is less than a minus x is less than delta. And since a is equal to 5, this means that we want to obtain the inequality 0 is less than 5 minus x is less than delta. In the inequality involving capital N, we factor out the denominator of the left side. We get for the left side 2x plus 3 over the product of the quantities x minus 5 and x plus 5. X minus 5 is just the negative of 5 minus x. And so we change x minus 5 to 5 minus x. But this changes the sign of the quantity on the left side. We should do likewise for the right side. We change n to minus n. The inequality also reverses direction. The result is 2x plus 3 over the product of 5 minus x and x plus 5 is now greater than minus n. We should point out that minus n is greater than 0 if we start out with n negative as stipulated in the definition. With both sides of the inequality being positive, we take reciprocals and reverse the inequality. We get the product of 5 minus x and 5 plus x over 2x plus 3 is less than minus 1 over n. Now that we've got 5 minus x in this inequality, we just need to find bounds for 5 plus x over 2x plus 3. These bounds should be positive, and we search for these bounds near x equals 5 and to the left of x equals 5. To find these bounds, we guess at a value of delta. Let us try delta equals 1. 1 unit to the left of 5 is 4. And so x is between 4 and 5. We add 5 to each part of this inequality. And we get 9 is less than x plus 5 is less than 10. We now work on 2x plus 3. We multiply each part of the inequality by 2 and then add 3 to each part. We get 11 is less than 2x plus 3 is less than 13. We get the reciprocal of each part of this inequality, and we get 1 over 13 is less than 1 over 2x plus 3 is less than 1 over 11. We combine these two inequalities and obtain 9 over 13 is less than x plus 5 over 2x plus 3 is less than 10 over 11. We multiply everything by 5 minus x. And remember, 5 minus x is positive. We get 5 minus x times 9 over 13 is less than 5 minus x times x plus 5 over 2x plus 3 is less than 5 minus x times 10 over 11. We want to make sure that the original n inequality stays true. And so we set 5 minus x times 10 over 11 less than minus 1 over n. And so 5 minus x should be less than minus 11 divided by 10 times n. And now we have two bounds for 5 minus x. These are our candidates for delta. The first is delta equals 1. And the other is minus 11 over 10 times n. To make sure that the original n inequality holds with our choice of delta, we choose delta to be the minimum between 1 and minus 11 over 10 times n. Now we slowly build up the n inequality. We first take aim at this inequality. We start with 0 is less than 5 minus x. And with our choice of delta, 5 minus x is also less than 1. Our choice of delta also implies that 5 minus x is less than minus 11 over 10 times n. 5 minus x being between 0 and 1 implies that x is between 4 and 5. Now we add 5 to each part of this inequality. The result is 9 is less than x plus 5 is less than 10. Now we target the denominator 2x plus 3. We multiply everything by 2 and then add 3. The result is 11 is less than 2x plus 3 is less than 13. We take the smallest quantity in this inequality and divide it by the biggest quantity in this inequality. And so 9 over 13 will be the smallest of the fractions that we will form. The idea is that with all the quantities being positive, the smaller the numerator and the bigger the denominator, the smaller the fraction will be. And so the next fraction is formed by the middle quantities x plus 5 and 2x plus 3. The largest of the three fractions is the biggest quantity in this inequality, divided by the smallest quantity in this inequality. Then we proceed to multiply everything by 5 minus x. We take only the rightmost two quantities. X plus 5 times 5 minus x is 25 minus x squared. We're still dividing by 2x plus 3. This is less than 10 over 11 times 5 minus x. Since 5 minus x is less than minus 11 over 10 times n, 10 over 11 times 5 minus x is less than 10 over 11 times minus 11 over 10 times n. Of course, this product is equal to minus 1 over n. And so we have 25 minus x squared divided by 2x plus 3 is less than minus 1 over n. We change the sign of each part in this inequality so that the inequality reverses direction. And then we take reciprocals, so that the inequality reverses direction again. We get the original n inequality, 2x plus 3 divided by x squared minus 25 is less than n. And so we have shown that the limit as x approaches 5 from the left side of 2x plus 3 divided by x squared minus 25 is minus infinity.